periodic table is home to over 100 different elements. Some of these we regularly interact with, and others not so much. In this video, we'll be exploring the key elements of the periodic table. We hope you enjoyed the video, guys, and remember to stay sciencey.
The periodic table was created to categorize every discovered and theorized element. On the left, we've got reactive metals such as lithium, potassium, and sodium. On the right, we've got the very unreactive noble gases like helium and neon. In between them, we've got your transition metals, your stereotypical metals such as iron and nickel. And just over here, we've got some semi-metals and non-metals like silicon, phosphorus, and some gases like oxygen, nitrogen, and chlorine.
Russian chemist Dmitry Mendeleev created the periodic table in 1869. As he was going about this, he left gaps in the table for undiscovered elements. He realized that elements are arranged in terms of increasing atomic weight, which is equivalent to the number of protons and neutrons in their nucleus. Whilst this is mainly true, there is one major exception. Here, tellurium, which has an atomic weight of 128, is placed before iodine, which has an atomic weight of 127. This is because Mendeleev realized that elements in the same column, or as we call them, groups, have similar chemical properties. Mendeleev realized that iodine has similar chemical properties to bromine, chlorine, fluorine, and astatine. This is why iodine is in group 7. So now we know that elements in the periodic table are actually arranged in terms of increasing atomic number.
Elements in the periodic table always have a mass number, an atomic or proton number, and a symbol. Here you can see hydrogen and carbon. Some other examples of symbols you might come across: F for fluorine, Li for lithium, and Cl for chlorine. Now, some of them have one letter, some of them have two. When they have two letters, you always start with an uppercase letter followed by a lowercase. When it's one, it's just always uppercase. Some of the symbols are named after their Latin names of the elements. This is sodium, its Latin name is natrium. Ferrum is the Latin name for iron, so Fe is iron. Boron is the Latin name for gold. Now, if you come over here, you'll see some molecular formula. You can use the symbols, as I've just shown you, to show molecules and how many atoms of each type are within a molecule. So O2 is the molecular form of oxygen, so it's just two oxygen atoms create an oxygen molecule. H2O, two hydrogens, one oxygen. Some others you might be familiar with: methane, CH4, as you might have gas stoves, heating anything like that, depending on where you live. And Fe2O3, two irons, three oxygens, that is more or less rust. Now, the periodic table, as Zed said, is made of groups, columns, and periods, which are the rows. Now, in each group, you have very similar chemical and physical properties. Noble gases, on the far side, group 0 or 8, are very unreactive, and as the name says, they're all gases. The group just before that, group 7, fluorine, chlorine, bromine, iodine, astatine, are all very toxic and reactive gases. They're not always gases, but always very toxic and reactive, and often diatomic, so they travel around in pairs like oxygen does, F2, Cl2, Br2, etc. Transition metals, this middle section, trying not to break the periodic table, are all, they're your standard stereotypical metals, very similar physical properties. This is a sample of nickel, transition metal, quite shiny and malleable when it's pure. Another sample of copper, again quite shiny, well, it's covered with a layer of oxide, which is another property that transition metals have. They can be oxidized quite often, so you get rust. This is copper covered with copper oxide, which is not rust. And this is zinc, again quite malleable and would be shinier if it wasn't covered with its oxide. But the best group to demonstrate physical and chemical similarities would be the alkali metals group 1.
The group 1 metals, like the other groups, show similar physical and chemical properties to each other. As you can see, the sample of lithium, like its other group 1 counterparts, is a dull grey solid that's quite soft and reasonably easy to cut.
Elements in the same group have similar chemical properties and similar reactions. I'll now be adding some lithium to some water. This is plain water on the right, and I've added some universal indicator to it, which essentially measures the pH of the water, which is how acidic or alkaline it is. So as you can see, it is green, which suggests that plain water is just neutral. So now I will add some lithium into a water drop. Now I'll add some indicator to this, just a couple of drops. So as it's reacting, you can see it's melting, which is from the heat of the reaction, which is causing it to melt. And you can see the water is beginning to go purple. That is due to the indicator, which suggests that something alkaline is being made as a product of this reaction. You can also see some bubbling, which suggests that some gas is being given off, in this case hydrogen gas. So up close you can see the bubbling. I add some more indicator. You can see that it's going purple, which suggests that something alkaline is being produced. So this sample of lithium will eventually melt. It actually melts quite quickly. So now I'm going to add some sodium, which is directly beneath lithium in group 1, to some water. So as you can see straight away, this reaction is much more vigorous than the lithium one. Now I'm just going to get some indicator again. You can see still the same purple colour, so still an alkaline product is being produced in this reaction. So as you can see here, it kind of melts into a ball shape, and it's fizzing obviously, which is the hydrogen being produced again in this reaction. So now I'm going to add some potassium, which is directly beneath sodium in group 1, to some water. So as you can see, that reaction is very vigorous, like really vigorous. Suggests that potassium is way more reactive than lithium and sodium. The periodic table is something scientists need to be familiar with and interact with to be able to predict properties and reactions of certain elements. If you're like us, you'll have a competition on who can memorize more of the periodic table. Courtney and I need to have a rematch. In the next video, we hope that we can use rubidium and cesium. Anyways, we hope you enjoyed the video, guys, and remember to stay sciencey.